Well, welcome everyone here in 408 Hayes Hall and all of you that are on Zoom with us today. Today is P Update meeting, presentations. And we're also having a big tour today for two of our guests. And so we're in the process of not only having the opportunity to meet here, but also in the field. Most of you know Jeff Berg. He's been on line for the last number of years, and he's the individual that has the opportunity to read all of your reports when you submit them.
Read everyone. What a great opportunity. Yeah, that's the word I use. Thrilled.
Yeah. And we have Reed Christensen. He's a new member of the Minnesota Department of Agriculture team, and that will be part of the team interacting with the Forever Green initiative over the next number of months and years, we hope.
Yep.
And so I want to welcome you to Minnesota and to the Forever Green initiative.
Thank you very much.
So we've started out this morning visiting some of the greenhouses and some of the facilities. Just left George down at the food science department, and then we'll be going out for a field tour starting at 2. So we'll have a little time probably after the meeting today for about an hour. So any of you that want to stay and have a conversation with Reed and with Jeff, we'll have some time to do that before we head out to the field at, I think, 2 o'clock. Yeah. So
why don't we give Reed a chance to introduce himself if you'd like? Do you mind?
Oh, sure. Yeah. My name is Reed Christensen. I joined the Minnesota Department of Agriculture in May of this year, so I'm caught up to speed. I'm a supervisor in the pesticide fertilizer management division. I'm focusing on clean water, and I came from academia. I was an assistant professor in crop sciences at the University of Illinois. And before that, that was another life, but I was a stormwater engineer before that. So, but yeah, I've been doing water quality work for quite a long time, and understanding or trying to understand the implications of our land use or land management on water quality.
thank you. So before we start each week, we also open it up for any updates from anyone online or in the room. Things that have happened recently or things that the group should know about in terms of updates for things coming up in the future. You're going to be defending your thesis here pretty soon, right?
Yep. Yeah. November 28th works for you.
Yeah. Any comments?
So just why I'm here, I mean, thanks for the opportunity to take the time to do the tour by Don and all of you, online, saw this morning, we see this afternoon. So as Don said, I get to read all of the report, and this brings it to life. So we're a lot of cases a silent partner, which is fine, but to realize that we help you guys out financially, technically on some of these things. So it's actually good to see those, and we're always available to answer questions and things like that, run ideas by, and many of you do that already. So appreciate it.
Well, we express our gratitude to you guys, often in person, but not very often in public, but we certainly do really enjoy the working relationship and the support that you've provided as individuals and as a program for the Forever Green initiative.
We do have a job announcement supported through MBA funds through the Forever Green Eco Implementation Program and the LCCMR Winter Camelina Project. We have available a full-time field agronomist position for perennial grains and winter annuals to support kinds of perennial grain, winter barley, winter rye, and I'm missing one. And winter camelina.
Definitely not winter peas.
Not yet. So the position just went live. I'll distribute it today. And it's a great job opportunity. I think it's a 2-year position, hopefully to be extended in the future.
I'll just give one update. Yesterday, there was a group of us that spent half a day out at Pierce in Dawson, Minnesota. And had a great conversation out there with a group of legislators from that region of the state. Opportunity for them to learn more about the Forever Green Initiative and the Pierce as a company. And what was really interesting, I think, to everyone was the framework for how Pierce got to where it's at. It mimics basically the Forever Green platforms, from basic research, breeding, the agronomics, and the food science. So I think everyone's kind of intrigued to sit back and think, oh yeah, there's the connection between what's going on in the Forever Green Initiative and a company, a family that went through that same process of getting pea on the landscape. But the other thing, and this is the pressure I want to put on you guys in this room today. Yeah, you two of you. None of the pea that's going through that processing plant is grown in Minnesota. Right? That's what I'm saying. There's the pressure. Right? So the opportunity is just huge, right, in terms of working with Pierce and their network of folks. Very excited to have this program here and being part of the long-term efforts. So the lead scientist for the P work that has organized the P program and pulled a lot of the federal funding along with state funding, Stupar. And we're glad to have him as part of that network of Pulse, the Pulse world. With his background, I think he's a major contributor to that work, not only here, but I think across the whole framework. And then Steve Mulkey, we're glad that you're here. Glad you're actively engaged. He's operating as a postdoc scientist that basically appears to me runs the program. Very fair. So today, it's an opportunity to give you guys an update, and then we'll also then hope to see you in the field maybe this afternoon to visit some of the fall planting. So Steve, it's all yours.
Okay, thanks, Don. So good morning, good afternoon now, everyone. Thank you all for being here, both in physical and digital forms. So today I'm going to be giving you an update on the work we've been doing in the last year on winter peas, specifically within the Forever Green framework. So just trying to show you guys all the ways we're planning on revolutionizing Minnesotan agriculture with the best of the legumes, winter peas.
He's got it down.
Okay, so for those of you who aren't forced to spend lots of time with me, I'll just briefly expound on the many virtues of peas. And the theme today is versatility. So winter peas are one of the few winter legumes that can be grown. And as such, they are great because they can hold the soil together in the fall and early spring months when usually there's lots of erosion. There's usually not anything on the field. And as such, they can help reduce erosion and help protect waterways, reduce runoff, that kind of stuff. And as a legume, they're particularly valuable because they can add nitrogen to the soil potentially on depending on how you use it. So for subsequent cash crops, they can add a lot of value. I also love peas because there are many different uses for them. So they can be used as a feed for animals. Both the grain and the forage has high levels of protein, which is easily digested. For non-livestock animals, so for humans, there are lots of different ways you can eat peas. You can have them in soups and stews. You can ground the grain into a flour, which can be used as a cooking ingredient. And then increasingly what's popular is through these purified plant protein extracts. And so this area has been what's really getting a lot of attention. There's a lot of market growth. So this graph just kind of shows that there's a lot of expected growth in the plant protein market coming up, and it's a very competitive market. And so all of you have probably heard of Beyond Meats. Those are plant protein, pea protein derived ingredients. So that's one of the things that actually really sets peas apart from many of the other winter legumes. There's already a very well-established market system for peas. There are guidelines and standards for food grade peas, feed grade peas, and other uses. And there's a whole infrastructure on extracting the protein and utilizing this whole industry. But to make peas work for Minnesota, we have a number of challenges that we need to overcome, right? And so the most obvious one is winter hardiness. So I have this chart here, and it shows the average high and low temperatures for both Pullman, Washington, and St. Paul during the 3 coldest months of the year. And the reason why I have this chart here is because historically all the breeding for winter peas have been done in Washington. And the point that I want to make is that you can see how much colder Minnesota is. So it's a much more challenging environment. So currently, farmers growing winter peas in Minnesota is a high risk endeavor. And that's never something a farmer wants to hear. Right? Risk and farmers don't go together. The other challenge beyond getting winter survival is just trying to optimize and figure out the agronomics. So this isn't my forte. This is where I really need to lean on others and their expertise. But how will winter peas fit into the larger growing cycle that farmers would try to use for Minnesota? Our winters are long, so by the time peas are getting off, it might be in some cases too late to follow up with the normal summer crops like soybean, corn, or the standards. So we need a buddy for peas. And so I kind of in my mind imagine, corn and soybean go together so well. I want a buddy for peas that is like the corn that can match it. So we need to work on optimizing these systems and figure out how peas can fit in. And there's, I think, a number of forever green crops that might potentially fit into that. So work for down the road. So once we start addressing those crucial issues, then there's the usual breeding objectives, right? So diseases, abiotic and biotic stresses. Historically, like nationwide, the root rots are the biggest problem for peas. But the last couple of years in Minnesota, we've been in severe drought, so that hasn't been a big issue here. The biggest problems I've seen are both aphids and powdery mildew, but that tends to be a much bigger problem in spring peas that kind of come on later in the season. So the winter peas actually tend to avoid a lot of that by finishing early. And then there's some other bacterial blights, but we'll see how these issues go in the future. And then lastly, there's the usual breeding objectives, right? We always want to be increasing yield, but we also want to try to focus on the protein side of it, increasing protein and also protein quality. Right? Okay, so I am happy to inform everyone that the Forever Green grant has been renewed. So we've got continued funding for this work. And the overarching goal behind the grant is to develop both winter and spring pea varieties for Minnesota. Most of our work is focusing on winter peas. That's what I'll be talking about today. But both as a cover and a cash crop. And I think the real key here is the cash crop part of it, right? If we really want to spur farmers to adopt winter peas, there needs to be a strong economic incentive. And so cash crops are where the money is. I think that's kind of long-term breeding what we want to strive for. The cover crop might be an early way to get in and get the farmers adopting it, but I think this is our long-term goal here. So to achieve this overarching goal, there are 4 objectives that are outlined in the grant. The first is to continue evaluating elite material and trying to identify parents for making crosses, right? The second objective is, once we have these parental materials identified, to start making crosses and developing breeding populations for Minnesota. And then the last 2 objectives revolve around developing proof methods. So objective 3 is developing genomic resources, just to try to investigate the major traits controlling winter peas, so like winter hardiness. It's a very complex trait. And then this last objective 4, evaluating the relationship between winter hardiness and xylem structure variation. So there's been in a number of crops some evidence that variation in xylem structure is predictive for winter hardiness. And if we can, if this proves to be true of peas, then we have a more high throughput way to investigate winter hardiness potentially. Okay, so I'm going to start by looking at the first objective, what we've been doing so far. So for the past 2 winters now, Bob and I have been evaluating 16 winter pea varieties, 7 of which we got from the USDA pea breeder out of Washington, and then another 9 from a private company called Progene, which is also based out of Washington. And they basically gave us material that they thought would have a chance of surviving in Minnesota. So on the left, you can see a picture of our field in April of 2021. So that year, oh, and I'll just point out, the big, really green, bushy stuff, that's triticale. That's not peas. The peas are here and here. So that's what they look like at the end of April in Minnesota. And so that winter, we actually had really high rates of survival, percentage of survival. So if you counted the number of plants in the fall, and then you looked at those same plants and counted the number of plants that were actually alive in the spring, the survival percentages were very high. But I did see a good variation for winter damage, so like spotting and leaf death. And so I took ratings on that for those 16 lines. And then on the right, you can see what our plots kind of look like this year on May 3rd. So the winter was endless this year. It just didn't want to go away. So that's May 3rd. Here is those same 16 lines being grown in the field on May 23rd. So we were almost a month behind. These are, again, triticale popping up. These are the peas, these plots here. And so you can see they were just about the same size at the end of May this year as they were at the end of April the year before. So we were like a month behind this year. But the data from the field this year was fantastic. There was a great spread for percentage of survival. Unfortunately, my winter damage ratings were not great because I took them at the end of March when actually all the snow had melted. But then we had another month of winter that happened. So that data did not pan out very well. So 2021, we have winter damage ratings. 2022, we have actual survival ratings. And so this is what that data looks like for those 16 lines. So you can see we have survival for one line that was 2% these are replicated. There are 4 reps for these lines, 4-row plots. And it goes all the way up to almost 80% survival. So that's what we're looking at. And I'll just also point out real quick, the lines in bold and green, these are the lines from the USDA. So these are lines that are publicly available. You don't have to sign an MTA to get a hold of the seed. And so Aaron Lorenz, who's not here today, who's one of the breeders here at the University of Minnesota, he assures me that I'm allowed to make crosses with that material. Throughout the growing seasons, I've taken ratings on a number of the 16 or 17 different agronomic parameters. That's kind of beyond the scope of this talk today to go into all that data. So I'm going to try to just show you 2 graphs for this. So this first one shows my early spring vigor ratings taken in June on the y-axis. So early is in quotations because obviously June 6th is not exactly early spring, but for this year, that was early. And this rating corresponds with when you might expect flowering to start in peas. And this is important because this is when farmers would harvest peas for forage. They like to harvest it right as flowering is about to start because that's when you have the most forage, but the quality is still high. And then in the x-axis, we have the dry biomass matter at harvest. This is not the seed weight. This is just the stems and leaves and stuff that's harvested. So this graph is a little bit of a little bit of a brag because the early spring vigor ratings were really well correlated with the final biomass rating. So I was pretty happy. My eye did a good job of discerning predicting what the final yields for biomass were going to be, right? And then this is the ego check. So it's the same y-axis, but on the x-axis now we have the yield, actual seed yield at the end of the season. And so it's not nearly as predictive. But this is okay, because what this tells me is that we can use my early spring vigor rating as a fairly accurate corollary for assessing the biomass harvest. So if we're trying to breed for cover crops that could be used for forage, then I can do a non-destructive, quick visual rating, and then still allow the plots to grow, and then still get yield data. And so I can breed for two different objectives at the same time with the same study. I don't have to have a separate study where I grow for forage and then harvest it destructively. Okay, so this is actually one of the things I'm most excited about in this talk. So I just talked to you about the 16 elite lines that we got, but we need to cast the net farther, right? That's not very much material. It's definitely a genetic bottleneck. So the United States USDA has a pea germplasm collection, which has over 5,000 different pea accessions in it. I scoured it for descriptions, anything that included like fall sown, winter pea varieties, frost hardy, cold hardy, all those kinds of descriptions. And out of those 5,000 lines, there were about 140 that matched. So essentially, this is the winter pea collection within the USDA material. So we took those 140 lines and we put them in the field this year. Now these are just single rows. They're unreplicated because I only get a small amount of seed from the USDA. But once again, the data was just fantastic. So there was a nice range of depth. And so you can see most of these plots are actually fairly empty. And that's because most of the stuff died. If you look at the graph on the right, it shows the percent survival on the x-axis and then the number of lines that fit into those categories in the Y. So most material died. But that's okay, because Minnesota is a very challenging winter environment. We expect most of these lines to die. I'll just also mention these 140 lines, they're from like all over the world. There's stuff from like Russia, Germany, and England, stuff from northern environments mostly. But what is really great about it is that there were a number of lines which had fairly acceptable levels of survival, and a few which actually had very high levels, 80 to 90 to 100% survival. And there were even a few of these lines which had like 100% survival, which outmatched the controlled checks which were included. So there was a few modern elite winter peas, including my winter, which was developed in Wisconsin, which I included in the study, and some of these lines did better than those checks. Or why, maybe not Wisconsin, sorry. And so these pictures just show what that looks like. So here we have complete death. Here we have maybe 5 to 10% survival. And then these two lines had maybe 90 to 100% survival. So that's what we're looking at here. And all four of these are, none of these are the checks, these are actual lines. Okay, so I took the same data set on all these lines, and I have this graph up here because I want to just make a few points. So on the y-axis we have yield, and I just wanted you to see that there was a large variation for yield, and this is to be expected because we also had huge variation for survival, right? So you'd expect plots with low survival to also have low yield. But a few of these lines actually had as good yield as the checks. So that was pretty exciting. The other thing I wanted to show were the days to maturity. So this is when you can harvest. And there's basically like a 2-week range this year from July 8th to July 21st when things were maturing. Now this is awfully late, right, for a maturity date. But remember, we were like a month behind. So in the summer of 2021, we were harvesting around the end of June. So that's around, I think, when farmers might normally in a normal year expect to be harvesting their peas if they're growing it for grain. But the real thing that I think is interesting here is that there is this variation, right? They're not all clustered at like just a small window. There's a 2-week window. And when I was first looking at this, my instinct was we got to select for the early maturing stuff, right? Like farmers are going to want stuff to mature early so that they can get hopefully a late planting for summer crop and fit into the rotations. But then I talked with Don, I talked with Jake and others, and maybe it could also be good to select in both directions, also select for later maturing stuff. If there are other crops that can fit in and are planted, late summer, then you're going to want to keep something growing on that field for as long as possible until it's ready for planting that stuff. Something to keep the soil together and suppress weeds. So we might want to select in both directions, and there's genetic variation there to do that. All right, so here we have some pictures of what some of these like 60 or so lines that survived look like. And so we have most of that material looked like these 5 pictures here. So huge variation for seed coat color, things like mottling, speckling, a little bit of seed shape variation. The bad news, this stuff is maybe feed quality. Most of it, these varieties are only good for forage. That is not like market grade quality. The great news, there were 4 lines that looked like this. So these have a clear seed coat, yellow cotyledon. These are food grade peas, which are the highest premium the farmers can get. And not only that, but they have decent seed size. So they're kind of like the hidden gems because, and one of them actually had some of the highest yield out of all these lines. It had great survival. So it stacks all the traits we're looking for. They have great survival, they have decent yield, and they have good quality. So we basically found through sheer fortune, I guess, sheer luck, a few lines which can go straight into our crossing block this winter. And so we're adding elite material that wasn't represented from the lines I already got. And we can add some more genetic diversity and winter hardiness into our breeding line. Okay, so that's the end of the field-based evaluations. Now I'll just talk about some of the work I've been doing to optimize protocols for using controlled environment growth chambers. Because while these last couple winters, while winters are great, like this last winter was the best winter for getting field-based evaluations for survival. You can only get one winter evaluation in a year, right? And you never know what you're going to get. Some years you might get complete death, other years there's not enough selection. So if we have a reliable, repeatable way to do it multiple times a year, this is the best for both evaluating progeny and also elite parental material, trying to figure out who's the most winter hardy. So this shows the pipeline. For those who haven't seen it before, it's basically just a couple weeks of establishment once you plant the lines, a couple weeks of cold acclimation. This basically mimics what the plants might be seeing in the field in the fall as it starts to get colder. That helps turn on genes for them to start getting ready for winter. There's 3 days of sub-zero acclimation. This helps turn on additional genes so that they get ready for being frozen. And then there's the actual freeze test. So I've tested a number of different temperatures, and I'll get into those details in a minute. And then you have a recovery period followed by evaluation. And I have been trying to do a couple of things. I've been hoping that as soon as the freeze test is over, I could move material into the greenhouses to get it out of the growth chamber and start putting another freeze test in to speed up the protocol, but added too much noise and variation. The survival ratings, and there was a lot more variability. It was not reliable. So fortunately, they have to stay in growth chambers for that 3 weeks of recovery period. I had been hoping that I could keep them in the growth chamber just for 5 days, as opposed to waiting full 3 weeks to make those evaluations. But again, there was just too much noise. It was not well correlated. So unfortunately, we have to wait those 3 weeks. There's no way around it. But in addition to evaluating different freezing temperatures, I, in my most recent freeze test, tried to double the number of plants I could fit into that growth chamber. So all these tests that I've been doing have been using those 16 elite lines that were in the field. And originally I had almost 600 plants. So 3 replications for all those lines, and each replication was based on 10 plants. So there's a total of 30 plants for each of those 16 lines. And that's where these scores are. But I doubled it. So they're going into smaller pots. And what I was worried about is that might add too much extra variation. Being in smaller pots, maybe the plants won't be as healthy, or there'll be some other kind of issue. And I'll get into the results of what I found in just a minute, so stay tuned. This is how I took ratings on that material. So it was a 0 to 5 scale, where 0 represents no damage at all, and 5 represents complete death. And then we have a gradient in between. And so, for those at home or those looking at the screen, I'll just kind of quickly explain how this scale works. So a 1 means there's just a leaf or 2, there's a little bit of damage, not much. A 2, there can be more widespread leaf damage, but the stems are still fine, there's lots of growth. A score of 3, sometimes there's a whole stem that died, there's a lot more leaf death, but there's also plenty of new growth during that recovery period. A score of 4, the stems are almost completely dead, the leaves are all destroyed. There's just barely hanging on, but they're still alive. And then obviously 5, the plants got blasted away. So this is how that data looks. And so I'll start to unpack this. There's a lot in this graph. So this shows 6 of the last 7 freeze tests that I've done. So when I was first starting, I was freezing at a pretty extreme temperature of -14 degrees Celsius. And we had a lot of death. If you remember, if you look at the y-axis, a score of 5 means complete death. 0 means that they were completely damaged. So mostly death. However, if you looked at the 16 lines, they were relatively consistent. So the best performers tended to be the best performers across all those, and the worst were the worst, with a little bit of shuffling in between. Freeze test 5, which I don't have shown here, was just like a small test, and I wanted to try a lower temperature. So I did -13 degrees Celsius, and I saw a much nicer spread in survival. So I did that with all 16 lines again for freeze test 6. However, I set it to -13, but the chamber only dropped to -12 for whatever reason. That's one of the issues with growth chambers. They don't always perform the way you expect. And there also is a lot of noise, which is why we have lots of replication. But we have this huge, or not huge, but a nice spread, I would say, of response. And the great news is that the good performers in this batch, in this round of experiment, were the best performers from the previous ones. It's just that we're able to tease apart those differences a bit better. So -12 seemed like a good temperature. So when I switched to this most recent test where I have 1,200 pots in the chamber instead of 600, I set it to -12. And here you can see the results. So we have even less death. Still a great range in responses. And once again, the best performers are still the best performers, and the worst are still the worst. But what I think is happening here, I think why we have so much more survival, is that the plants are actually insulating each other and protecting each other. So when you really pack them in like that, there's lots of green tissue up here, there's lots of small pots, and so they're insulating each other. So they don't get quite subjected to quite the same degree of freezing. The actual freeze temperature is just for 2 hours. So I might try to up this temperature in future tests. Freeze test 8, I will be scoring in a couple weeks. I'm excited about that test because it's going to be on breeding material that I've been developing. And then the last part, I'll just mention, I have the R-squared values for these different tests. So it's just a simple model with variety, replication, and then the interaction between those two. And what you can see is that overall the R-squareds are pretty low, right? Some might say it's kind of alarming, but this is actually very normal for freeze tests. Even though we're trying to control all these different parameters and we have this controlled environment, which is trying to keep all the plants at the same temperature, it's very normal in freeze tests with these chambers that you have a lot of noise. And that's why it's important that the results are based on 30 to 60 plants for each of those varieties. And so while we have a bit more noise for the smaller pots, we also have more replication. And so we can still use this and have a more high throughput way of evaluating pots, I think. And then this graph just shows what that range of variation for those 16 lines look like. And so again, the lines that are in green and bold here, those are lines that are from the USDA and are available for crossing and for breeding right now. I also forgot to mention, so these other lines from Progene, I've been actively talking with the breeder and owner of Progene, and they're very open to the idea of us making crosses. I think that I've convinced them about our goals of just trying to improve peas and build the pea community, not just for Minnesota, but abroad. And that aligns with their own company goals. So I'm hoping maybe this winter or in the next one to start incorporating their material to the breeding pipeline too, because they have some great stuff. But some of the best material that survived is stuff I can already make crosses with and have been making crosses with. So that's good. So these growth chamber tests, they evaluate one facet of winter survival. They look at freezing tolerance. Winter survival is a very complex trait. So how well do my tests correlate with winter survival? On the left, we have, so on the y-axis, we have the freeze chamber scores. And then for this graph, we have the winter damage scores I took in 2021. Remember, we had high survival that year, so I took winter damage scores. And then on the right, we have field survival from this last winter. We had great variation for winter survival, but not very good variation for the winter damage. And so what's going on? I think the relationships are fairly good. They're not completely amazing, but they're fairly good. Why does 2021 look better? So here are the R-squareds. I think there's a few things going on here. And so the first is that the winter damage ratings are very similar to my freeze test scoring system, which is a bit more nuanced than just death or survival, right? A score of 5 in my freeze tests or 9 in the field represented complete death. But then I have a range of how they responded on top of that. The second problem is, or maybe one of the second sources of variation, why they don't match up perfectly, is that we're looking at 2 different parameters. And then the third is that there's year-to-year variation, right? So not all winters are the same. And there can be things like moisture in the field, topography in the field, and very small variations can really impact how things survive in the field. So there's a lot of noise in field data. Yeah. But I think, the point here is that the freeze chambers allow us to investigate maybe the most important facet of winter survival, which is the freezing tolerance. And it's the aspect that we can select on and is genetically controlled. So I think that these growth chamber tests are adequate high throughput ways of evaluating material. Okay, so that's it for evaluating parents. So now I'll start to talk to you guys about our efforts and successes in our breeding. So I've got some pictures here. That first winter of 2020/21, we started making crosses with those USDA lines in the greenhouse. That material then I grew in growth chambers. I grew the F1 progeny growth chambers. This last year, I had F2 winter peas in the field during the spring. So this fall, I will have F3 lines in the field this winter.
Do they require vernalization?
They don't. So they're not like a small grain. They don't actually require vernalization. The flowering for them is just controlled by day length.
Nice.
So they just need a long day.
Makes for a quicker breeding cycle then.
Yes. And I'll get to that in just a moment. That's a great point. So here are F1 progeny that are growing right now in the Borlaug basement. These are progeny processed from this last winter. And then we also have in the basement of the plant growth facilities, F3 progeny. So these are progeny from those same F2 lines that were in the field. And so the reason why I showed this picture is because it might be hard for you to see, but these are smaller pots. So one of the things I've been trying to do is try to find ways to speed up the breeding pipeline, right? And get more generations in a year. So we can make faster selections and all the things. So one of the things I've been trying to do is get them into smaller pots. I recently read a paper where they used a combination of smaller pots plus some plant growth hormone to keep the plant small while not inhibiting flowering time. And they were able to get 4 to 5 generation cycles in a year. So I am hoping to try to implement something like that. So this is the beginning of that kind of project. So we've got our fingers in that spice. So that was a great point you just made. Here is a picture of the field this year, this fall. So for those of you who I'll be showing, this is what you're going to be seeing. And there's a lot going on. I'm not going to get to all the details. This is a timing trial we have going on with 4 different planting dates. So we're trying to identify the best time to plant winter peas in Minnesota to get good survival and good yield. Now, I can see Don smirking over there because he's told me how he and Craig Schaefer have done this work before and investigated the best planting time. And he would say, middle of September is when you should be planting. And I would say, I agree with you. However, I would also point out that even in the last 10 years, the genetics of winter peas has been improving. There have been selections. So the genetic landscape for vines is improving. We also have climate change. So I think it's prudent that we continue to evaluate this and try to make sure we're staying current and optimal for growers. So that's my response then. All right, the green here are those 16 lines. We actually have 18 lines in here now in replicated field trials. So another year of evaluating how great they survive. The yellow block here are those 140 USDA accessions. So they're going to the field for another winter. And then I'm also hoping to start doing freeze tests on them. And as far as I know, this will be the first kind of comprehensive evaluation for winter hardiness and freezing tolerance of the whole USDA winter pea collection. So I'm pretty excited about that. The thing that I'm most excited about is this purple block. So those are our F2-3 lines. So the first Minnesota-derived material being tested in Minnesota this winter. So I'm pretty jazzed about it. Okay. I'll just show you one of the crosses. So from those F2 plants that were rows that were in the field, these are individual harvested individual plants. So these are seed, F3 seed from those individual plants, all from the same original cross, a cross between this line Spectre and this line Lynx. So these guys are all related. They're derived from the same cross. But look at the crazy variation here, which doesn't match the parents, right? So Lynx is a clear sea coat, green cotyledon variety. Spectre is a yellow cotyledon variety with what's called ghost modeling. And so a lot of this darkness, which you can't really probably see too well, that actually comes from modeling. So these brown spots on the sea coat, and that modeling can be mild, or in some cases cover almost the entire sea coat. But all kinds of unexpected variation. So genetically very interesting. What's going on? What traits are controlling this? The yellow and green cotyledon, that's been well worked out. That's like Mendel's genetics from hundreds of years ago. But the sea coat stuff has been less focused on. So that's interesting. But more importantly is the seed size variation. So look at this line. The scale might be hard for you guys to see, but these seed are much bigger than either of the parents. So, and then some lines have variation for seed size. Some are small, some are larger, some are segregated for size. So genetically, what's going on here is very intriguing because as far as I know, seed size tends to be a very quantitative trait with a large variation. But this seems to indicate that there might be a couple genes that are actually having a huge effect on seed size that we didn't realize about. So that'll be good to know.
Is the dark color a problem?
Yeah, it's not desirable. So yes, it's a problem.
Is that why the dark ones are not food grade?
Yeah. Well, I'm not sure exactly why they don't like that for food, but I think that the seed coats are also thicker. It's also harder to tell if your seed are like diseased or gross.
Or does it color the protein
Say what?
in the processing?
Oh, that's a great
Maybe,
point.
yeah.
It might also, yeah, it might contribute that. And I think that there might also be like flavor components that they contribute as well. But not only from an interesting, like not only is this cross a gem from an academic standpoint, but we have some new Minnesota lines that are food grade peas. So from a breeder and end use standpoint, just very exciting.
And
So
you'll- and
hopefully
you'll-
they have good winter survival this year.
That's right, but you have those in the field, right?
These are going into the field as well as free trade tests.
How does it compare to that accession you found? That was like a really nice accession that kind of looked like that in terms of seed size too.
It's very similar. Yeah, they look very similar. So they have a larger seed size, which is very desirable. And then the other traits. Okay, so this is my work in progress, the breeding pipeline. So I'm not gonna like go through all the details with you, but as I've been working with winter peas and learning my crop, I've been trying to incorporate what I've learned into a breeding pipeline to try to optimize when to make selections for different traits. So there are a number of low-lying, easy traits that are controlled by just a single gene or just a couple of genes. They're easy to select for. So selecting them in early generations. I've been trying to figure out how to incorporate freeze tests and growth chambers to maximize how many breeding cycles or growing cycles we can get in a year. So what I'd love to do is talk with some of the breeders here at the university and spend some time with them and try to figure out what's the best way to incorporate stuff like the freeze tests to make selections of early generation material and how to incorporate it into the pipeline in the smartest way. Okay, so that's the main work where we have progress to report.
Steve, there's
Yeah.
a few questions from David
Oh.
Marks. I don't know if maybe you want to check those out. I can read them out if that's easy.
Okay, let's see. Has susceptibility to SCN been tested? SCN is,
Soybean resistant nematode.
oh, for bees?
Yeah.
I don't know of any, I don't think it's a normal problem. I haven't heard anything about nematodes. I think that most of the root problems are fungal pathogens. There's like a slew of fungal pathogens that work in concert to kill bees, but I don't know much about nematodes.
Yeah, I know we haven't looked at this question, but I do think we should read up a little bit about it now that Dave brought it up, because the soils that peas are grown in the Pacific Northwest are probably a lot less likely to have SCN in it than our soils.
Yeah,
So we probably want to look at that. That's a good, very
that
good
is a good point. Yeah. David also said that icicle looks good. I agree. I think icicle. So the two most hardy lines from my experience are icicle and Melrose. Unfortunately, icicle agronomically is not all that great. It has poor germination rates, and so not many farmers are going to grow it. But in the freeze tests, it appears to have a different mechanism of survival than Melrose. So Melrose will take damage, but just continue growing and it doesn't care. Icicle, usually, if it survives, it has very little damage. If it dies, like if there is damage, it usually dies. But I think that genetically it's got something else going on. So for preparing for crossing, I think it's definitely worthwhile. Unfortunately, for Minnesota growers, I don't think it's a great variety.
The thing that struck me was that it showed really good correlation between the
Yeah.
So
freeze.
it's one of the lines I'll be allowed to make crosses with. David, I can't really hear you too well. Are you saying something?
I'm sorry, I'm trying to. Can you hear me now?
Maybe if you could type it, because I don't think anyone else can hear you either.
It can't, isn't it on?
I'm hearing them. I'm hearing them on my.
Okay, it was just good correlation between the freezer test and winter survival for that one.
Okay.
It's not hooked up to it.
I think I may need to exit the whole thing.
I
Good.
think they'll go to the top. The sun settings over here.
Oh, owl? Maybe. Hey, David, do you want to try again?
I will, I'm typing too, but just a good correlation with that one between the freeze test and winter survival struck me.
Struck you in what way? Oh, the good correlation. Yeah. Yeah, I mean, I think that the freezing tolerance is the most important component of winter survival. It's a very complicated trait, and there's lots going on for winter survival. But I think that it's why it's not a perfect correlation, but I think it is a useful predictive. Okay, so we'll get back into it. People can see that. So that's where most of the progress that has been made in the last year. This fall, I'm hoping to start moving forward on objectives 3 and 4. Lost my laser pointer. There we go. So objective 3, we're going to be sequencing Melrose, which I was just mentioning. It's one of the hardy ones that survived. The current reference genome for pea is a spring pea variety from France. There's a number of sequencing projects underway at other institutions, but I believe this will be the first winter pea variety that's getting sequenced. So for us, I'm very excited about that. As another component of this objective, we're also going to be developing a mini nested association mapping population, mini NAM, with winter pea varieties. So like I said, winter hardiness and freezing tolerance is a very complex, highly quantitative trait, lots of genetics going on. So hopefully this population will allow us to start to tease apart these really complex interactions. And then for objective 4, I'm hoping our newest hire, Grace, who's in the audience today, can begin taking some sectionings. So now that we know that those 16 lines, we have a really good idea of who's the best and who's the worst. We have that variation. So now we need to start examining that xylem structure variation and seeing if it correlates with our field and freeze test data. So I'm hoping
tell them back file this is. I mean,
am I allowed? I guess, yeah, I guess I can explain that. There's a collaborator who's been helping us, and I don't want to like overstep. But I think the general idea is that smaller xylem structure is correlated with improved survival. Yeah. And it's been shown in small grains to be true. So is it still applicable to peas? We don't know. It's a very different crop, right? Yeah. But ideally it would be, because then what you can do is you can take sections on leaf or stem material of plants that are growing in the greenhouse. You can take sections on that stuff. You still have the plant intact in the greenhouse, and then you can see who's the best and who's the worst, and you can make selections without having to do a 2-month freezing test in the growth chamber. So more high throughput, improve that breeding pipeline.
That's high throughput.
We're gonna find out.
The 2-month freeze test.
You gotta cut the stem.
if he said it was, it was.
I said more high throughput. So we're working, we're doing what we can here. Yeah. Once we get markers, molecular markers, then we can do real high throughput. But you know,
So because
next
year his eyes are about that big.
Developing molecular, well, we'll get to that in a second. Okay, so that's the gist of the Forever Green stuff that's been going on. I'd just like to mention some of the other projects that we've got going on for those of you who aren't aware. So in addition to Forever Green, which focuses on winter peas, we also have a couple FFAR grants with spring peas. And a lot of that work focuses around looking at genetic diversity among spring peas, as well as diversity for protein content and quality. And then also trying to develop and see if NIR can be used to predict protein quality. So the idea behind that is NIR is a really high throughput, cheap way of evaluating material, and you can evaluate small volumes of seed. Whereas traditionally, if you want to look at protein quality, you need tons of seed to do it, and it takes a lot of time. So trying to have a high throughput way to look at end use quality. So obviously that would be really important for breeding work. And that's in conjunction with Pam Ishmael at the Plant Protein Innovation Center. Another project we've got going on in collaboration with people in New York, Wisconsin, and Michigan, Montana. I think Montana is this timing day trial that I talked about earlier, which Don is poo-pooed with winter peas. And then the last of our funding grants is another one with Pam Ishmael at the Plant Protein Innovation Center. And this one is investigating potential differences between winter and spring peas for protein quality. So all the work that's been done to date on protein quality in peas has focused on spring peas. That's the majority of peas that are grown for human consumption. So to my knowledge, this is the first project that is investigating winter peas specifically to look at how their quality stacks up and then to see if there's differences between winter and spring pea varieties. And then there's like lots of unfunded projects, but I won't get into those. Okay, so looking forward, these are projects that I'd like to see happen that go kind of beyond the pale of this grant, but I think are essential for the work we're doing for Minnesota. So the first is to start developing mapping populations where I can start investigating some of those seed size and quality traits that I talked about, and we have some potential lines that are available where we can start developing them, as well as seed composition, so end use quality, protein content. Another important one is trying to, and I've talked a little bit about this, trying to integrate those freeze chamber tests into the pipeline in the most effective way. And so I've got some reading material that is being evaluated right now in these freeze test chambers. So what's the best generation to subject these early lines to cold stress and then select the best ones out of those tests? Right? So instead of having to wait for winter to do these tests, make multiple generations of stress and selection in a year. This third objective is going to start this fall in the crossing block, but I'm going to start making crosses between spring and winter peas. So you remember the 5,000 lines that the USDA has, the majority of them are spring peas, right? That's where most of the genetic diversity of peas lives. And most pea varieties that have been developed are spring peas. So in terms of breeding objectives, that's where a lot of the genetic diversity is. That's where a lot of the quality traits and yield traits are going to come from. So I'm going to start trying to bring that into our winter peas. And then lastly, this is my pie in the sky, right? So start to develop some high throughput markers that we can use for genotyping and genomic selection. So to Jake's comment about that's high throughput, this would be okay, so there are a lot of people to thank. So everyone from the Stupar lab, Bob himself, huge thanks to our newest hire, Grace. She's been fantastic. She is helping me get all kinds of work done. She's making these projects possible. And everyone in the lab. We had a few undergrads who are formerly with us or still with us, Thomas, Curran, Sagram, doing a lot of the grunt work in the field. Here's a picture of Grace and Curran at the end of the winter pea harvest. So happily waving their sickles around, happy that they're done using them. I'd also like to thank the co-PIs on these and our other grants. And then I'd like to give a special thanks, even if they're not here to see it, to Ed and Guillermo from the Smith Lab and Susan and Nate from the Anderson Lab. So I don't know if Kevin or Jim realize it, but their machinery and their employees have been doing a lot to help us get all these peas planted. So I'm very thankful because it wouldn't have been possible without their help. And then of course to Don, and then also the other Don Veldson, who's loaned out push planters to get a lot of material into the ground. And then to all the sponsors. And so, we have a lot of grants going on, but I'd just like to say that this all started with Forever Green. They gave us our first grant to get started with winter peas, and that gave us the launching pad, the platform. So a lot of these other grants we probably wouldn't have gotten unless we had been started with Forever Green. So, and the continued support is amazing. So thanks to everyone who's had their hands in that. All right, so I guess more questions if anyone's got any.
Yeah, thanks, Dave and Bob. Any comments online, questions online, conversation?
I have a comment, Don. Can you guys hear me?
We can.
Okay, so I really love peas. I had them for dinner last night. You talked about your growth chamber experiments, and it's somewhat of a concern to me because cold stress is never a situation in which, or rarely is a situation in which you have cold coming all of a sudden. It's something which comes gradually. And so stress priming is an important part of survival. And at least as you describe your growth chamber experiments, you're giving a catastrophic exposure to cold. And stress priming varies across different varieties. And so in the lack of having a stress prime, you probably are not ascertaining what you consider normal winter survival in your chamber experiments. So it's just a caution. I will throw in one of my papers into the chat so you can actually read about stress priming, because we did quite a lot of work in that area. The second one is a lot of the experiments you described with pea. One of the reasons pea is my favorite plant is because it has a novel auxin in it, 4-chloroindolacetic acid, which controls pea pod elongation. It's quite different than Arabidopsis because Arabidopsis salique is nothing compared to a pea pod in size. So that means that there are a couple of things to consider. One is even though we don't have chlorine deficiency in soils in the upper Midwest, it is a variable, and pea pod size, and probably as a result of pea pod size, seed size is going to be related in some way to chlorine availability. And since, even though chlorine is hardly ever low in Minnesota soils, it can be. And so it's just at least something to think about. It also gives you a target for some of your size selections, because there are very novel genes involved in chlorination of tryptophan and ultimately chlorination of indolacetic acid, which is absolutely required. It's the only auxin that controls pea pod growth. So I just wanted to add those two things to the work. And I'm happy you're working on peas, because it's a fantastic plant, not only because it has this wonderful, unusual auxin, but for lots of other reasons.
Yeah, thanks for that, like a bit of wisdom. I definitely didn't know about the chlorine or the potential issue there. So that's exciting to learn about. I'll give I guess a quick response to the freeze test stuff. So I mean, I agree with you, right? The freeze chambers, like, there's no matching of a good field year, because they're getting, like, there's a whole fall where they're acclimating and then being subjected to stress. The freeze chambers are really just like a proxy, so they're not going to be perfect. I know that Nick Weering did a lot of work where he gave the plants, he tried to do a better job of matching like fall, instead of just, like I just have dropped the temperature to like 10 degrees Celsius, make it cold. Yeah. Yes. Yeah. And I think that does do a better job of approximating the response. But my goal here is to try to find the balance, right? So by trying to like super fine tune that, it adds a lot of labor, and then also potentially takes a bit more time before I do the actual test. So I mean, I try to give them a little bit of cold.
But it's not like you have to invent. It's not like you have to invent a new way of priming, because stress biologists have come up with standardized methods for priming to do those tests that seem to work pretty effectively. Like you give a pre-cold treatment, say 48 hours before you give them the more rigorous cold. So priming, I mean, so you don't have to reinvent a mechanism. You can probably use an established protocol, which at least will wrap into your system you know, what happens to these plants if primed? Because that's an important question in terms of.
You do prime.
Yeah, but I mean, there is, you know, first there's the dropping them to 10 degrees so they get cold, and then there is a -3 for 3 days to turn on those final, and then they get dropped to the final temperature.
I think you also might, I mean, I think, yeah, Matt, I think what you're doing makes good sense for your first cut. In the future, you might also think about, like with your really promising candidates, like the freeze thaw cycles also.
Oh, yeah.
And that's kind of, and you, I mean,
That's a
you,
beast,
right,
yeah.
and you said this during your talk, that this is a first cut and that like controls on winter survivability are really complicated, but the direction of climate change in Minnesota is that we'll start to see, you know, our nighttime lows are getting higher. And so we won't just have this like deep chill, snow, stay cold all winter. We'll start to see more freeze thaw cycles too. And that might.
I'd almost call it spring survival. Like,
yeah. It's like, and like
Yeah.
repeated spring survival.
Yeah.
but yeah, I mean, like so yeah, that might be like a phase 2 that you might think about too. But you want to get your first cut. Just
If you want to model Minnesota weather, you need to go into our next series of experiments, which is we call multiple stress interactions. And that gets to be a lot more complicated, but at least in terms of stress priming, you'll see that a lot of plants, once primed, are really quite much more resistant than they are without priming. And other plants do not prime well at all. So if you're actually doing a genetic screen, you want to screen ones that behave under field conditions. You want ones that prime well and then survive. So that would be my only comment. I think it's worth considering that in the model because it's going to give you a better approximation to winter survival. And then you can come and talk to me about multiple stress, and we'll talk about that's a whole different.
All right, thanks, Jerry. Yeah.
Would you talk to us about whatever you know about the progress of the work that PPIC is doing? For example, in the FFAR funded project.
Do you want to take that one, Bob?
Do you have any sense of how that's coming?
So PPSC.
PPIC.
Oh, the Plant Protein Innovation Center.
Ah, right.
Yes.
So what are they doing? You want a little bit more information?
Well, yeah,
they are.
Broad strokes what they're doing, but
Yeah.
how's it going? You know, I mean, that's a complicated situation.
It is. So there's, I probably am not fully qualified to, I'll give you, as you say, broad strokes. My understanding is that they're really focusing on the protein chemistry side. And so what they're doing is they're trying to essentially, so there's in storage proteins of seed crops, mini seed crops, there's a couple different families that are really prominent, and they are generally called, there's different ways to call them. The simplest way is called Mc7S11S, which is basically the size of the protein molecules. And they're looking at the ratio of those two molecules and how that affects functionality of the protein. Because what they want to do is, it's going to sound funny, they want to, in the PPIC's ideal world, they want to make pea protein as functional as soybean. And so Pam Ishmael is trying to see if altering the ratios of those proteins will help us to get towards that. And then we could use that information in a breeding program to select for types that have these types of rates. So there's different ways to, there was actually a talk just on this yesterday. There's lots of new ways to phenotype seed composition at sort of high throughput ways. So the goal of that project is mainly to just come up with a better phenotyping scheme for breeding and selection for functionality traits. So that's a very short version of a much more complex series of experiments they're doing over there on this topic.
Before we could even get to that, they had to first find optimal ways to purify the 7 and 11S proteins from peas. So they had to work that out, which they have done, and then they've begun mixing and matching different proportions and stuff.
So we're working with Aaron Lorenz's group also on the side of trying to figure out if NIR could then be used as a way to identify those protein ratios that would then let us very quickly select which lines are most promising in our breeding.
And screen lots of lines. 'cause it's
Yeah,
so
that's right. It
easy.
gets through a lot of lines that way because Pam's chemistry is very, very good, very detailed, almost perfect, but it's not fast. You can only do 50 lines or so in the scheme of our project. I think it's 50 lines in a year or something
Yeah.
like that. Whereas NIR, you can do 50,000 just in that same. It's it's a huge difference.
Steve, you mentioned a mini
Rename.
mini NAM. What do you mean by mini NAM?
Okay, so the nested association mapping.
Is it just like the number of parents?
Yeah, so we'll
Okay.
have a hub parent and then we'll just have a small number of crosses.
So normal is like 10, but mini is 5 or
I think
something?
normal is even more than 10,
There's
right?
normal.
Well,
more than
there's
10?
no, I mean, there's no formal definition of how big it needs to be, but most NAMs that are out there have at least 25 parents.
25,
That's-
okay.
We're actually going to be making a spring bee AM as well.
Yep, and that's,
Another one
I
of the
think,
small objectives.
we're at like 32 parents there, I think, for that project.
So the winter one's gonna be quite a bit smaller.
The
Okay.
scale of this, all of this stuff gets big fast.
Yeah.
I laugh in part just knowing how, so this is where these populations, these NAM populations that they're describing would be, 5,000 lines. And they're really, really powerful for understanding the genetics of the
All
system.
kinds of genetics.
But it's so we're not just creating this for ourselves, we're creating it for hopefully the whole entire community of researchers.
We're gonna need a second grace.
Yeah, I know.
Yeah. And speaking of Grace, does she have any maybe time to work on double haploids?
No, she doesn't, because we've got so many projects. The mountain of stuff I want to give her to do is already this big. But I have thought about double haploids. But that's
Is
another.
there anything known about double haploids?
In peas? I don't think so.
I'm
I
guessing there
mean,
isn't, but
yeah.
I don't know.
I don't think so. I mean, for my PhD, I came from a wheat no breeding lab, and we actively use double haploids for the breeding of wheat. So I'm familiar with it, but I don't think it's been done in all of these.
So the advantage of that system is you can go from like a F1 hybrid to an inbred line really, really quickly.
One
It saves
generation.
years of time. Of course, if Steve's got his 4 to 5 cycles a year going,
That's my alternative.
Yeah.
then we won't have any problem getting to inbred lines quickly.
Yeah.
There's a couple more questions and comments. David, again, good comment suggesting that you could look at whether NIR soybean calibration equations or for pea. Same thing they did using canola equations for pennycress that was very effective. So,
I actually don't really know how similar those equations are, but there are people who have been using NIRP for a while, so we're probably, I don't know, we'll talk to them and see how similar that is. Yeah.
and then Carmen Fernholz has a couple of questions. Any data on the planting date, as well as dates and amounts of snow cover? And the follow-up question is, when do the peas actually succumb to the stresses?
Good question. All right, so planting dates, like Don predicted, mid-September seems to be the best time to get stuff there. That's where we have the highest survival rates. I don't have specific data for like how much snow cover we've had, but that is one of the most important factors for winter survival, because the snow insulates the peas. So if we have a year where there's not much snow, we're probably going to have much higher rates of death. Unfortunately, that's not something that I can control for. All right, for succumbing to stress. Yeah, so when the snow first melts and you look at those pea plants, they look green. Actually, well, the really not hardy lines will be dead, but many of them will be green. They've basically been damaged, like fundamentally damaged beyond repair, but they've been preserved in the snow and ice and cold. So then as the weather warms up and metabolic processes get underway and they start trying to grow, but their xylem are completely damaged, they start dying. And it can take a couple weeks to really be able to tell for sure if something is going to make it. So it's basically like the freeze tests that I do, right? I was hoping to be able to evaluate them after 5 days, but you would have to wait for 3 weeks before you evaluate that.
And Carmen, and out at your farm, there's never plant damage, ever.
Let's see, Nigeria.
Yeah, go ahead. I had interference here. What was the question?
I said that at the A3 farm, there's never any plant damage.
Never, ever. Right. But no, I was just curious about these questions because, snow does vary out here significantly from year to year, including the cold winds that follow the snows.
Well, okay, so another follow-up for your question then, I'm not sure where your farm is, but I'm also going to say.
Straight west, right next to the South Dakota border.
Okay, so I mean, as long as the latitude is the same, it'll probably be okay. But the farther north you get, you're gonna want to plant, I'm assuming, a little bit sooner before the winter comes.
Okay.
So what's the best planting date for St. Paul or, this area is not gonna be the same as northern Minnesota, but I don't think they'll survive in northern Minnesota yet anyways. You gotta do some reading.
Good, good.
Any other comments online or questions here in the house? This is one other interesting item, right? The department in here, around plant genetics is Gary Muehlbauer, right? Gary Muehlbauer grew up in Pullman, Washington, and his father, Fred, is the guy that ran the Pulse breeding program that all the germ plants that we're talking about had a major hand in over his entire career.
A lot of the pea variety releases, actually, the Muehlbauer name is on them.
Yeah, I was gonna say, a lot of your lines in this presentation are probably Fred's.
That's pretty cool.
Fred's releases.
I should tell Gary thank you.
Yeah.
Isn't that funny though, that connection, right?
For Washington State.
Yeah. Well, thanks for everyone here in the room today. Thanks for your participation. Thanks for all the good questions. And for those of you online, we're glad to have you on Zoom. We'd love to have you show up on in person, but if you can't, stay online and show up with us every Friday. So it's a great update, great conversation, and Steve, excellent presentation.
Thank you.
You're making great progress.
I'm very excited about these.
Yeah. And Bob, thank you.
Yeah. It goes without saying.
Take care, everybody. Have a good weekend.
Yeah.
Thanks.
All right. So